Welcome back. In this lesson, we're going to look at forecasting the weather. So can you guess what it's going to be weather-wise today or tomorrow or next week or 6 months from now? There is some clues that can allow you to look a little bit into the future. It's not really black magic. It's just looking at the situations, knowing that those situations are likely to produce events that you then taken with consideration, and knowing that you're most likely going to be wrong when you're listening to the weatherman, that in a lot of times it can give you a heads up in terms of the weather. So let's look at some examples. So forecasting the weather is a little like forecasting the future. I suppose it's possible to get it right sometimes, but you're going to get it wrong more often than you get it right. The situation about weather is that weather is always going to be the same if the same situation is exactly the same, which it's not. You've got different amounts of water, you have different amounts of wind, you have different amounts of heat, energy stored in that water. So you will always have it in slightly different ways. Remember that wind always blows from high concentration to low concentration. So it's not just the conditions at that very place, but it's the conditions around everywhere else that's making whether it's going to come in one direction or not. So there are some tricks that you can use, and it is a science, but it's also an art. So the first thing I want to mention is the station model, and the station model is one way to crowd a ton of information together. So a station model is for a specific location, so any particular location, any hillside, any town, and you are going to have the direction of the wind and is it cloudy or is it clear, is it overcast, what's its temperature, what is the precipitation at the moment, what is the temperature that it will drop its water, so that's the dew point. And then what is the pressure? What's the barometric pressure at that location? And what is the pressure at sea level at that moment? All of those different things can predict, or at least be used to predict, what's going to happen possibly in that area weather-wise. So when you plot a station model for an entire region, say the United States, you're interested in a lot of different things, but it's impossible to put everything in the same picture. So the first picture here is a picture of equal pressure, and these are lines of equal pressure. So anywhere that the same pressure is, you're going to have ISO bars. ISO means same, and then the bar is barometric pressure. So it's a pressure similarity, and you can see almost like a topographic map where you'll have certain pressure that's low and then certain pressure that's high, and you're going to have a gradient from low to high. If you remember that the wind will always blow from high concentration or high pressure to low pressure, and that's what high and low means in this case. It's air pressure. It's the pressure of the air molecules either shoved together and forming high pressure, or shoving or being very absent, then forming a low pressure. And then you will, in this sense, have something of a wind blowing from the southwest to the northeast in this case. You're also going to have winds blowing from the northeast to the Midwest. So just because you have winds blowing in different directions, it makes it very, very hard to specifically find out or to predict what exactly is going to happen. So a lot of times it's going to be based upon past histories, and we'll talk about that in a minute. So another type of map is not pressure, but temperature. So isotherms, iso remains the same, is a line where every point on that line is the same temperature. So anywhere in the dark red would be 100, and anywhere in the brick red would be 90, and then it just gets to less and less, and eventually goes from red to blue, and then blue being, Arctic chill, and then red being sweltering hot. So the heat has a lot to do with the energy that the water is possessing, and the water, that energized water, along with the winds, is what's basically making weather. Now, another thing to remember is not just that there is a high and there is a low. You remember in this top case, the wind will blow from high to low. So you have a certain pressure, in this case 1,012 millibars, and then to 1,000. So you have a little bit more push on the left, a little less on the right, and so the wind will blow gently from the left to the right. You're going to have, on the lower example, you're going to have 1,012 and 1,000 millibars there, and that is still just 12 millibars difference. But when you're talking about 20 kilometers apart rather than 100 kilometers apart, you have a serious change in pressure. So from high pressure to low pressure in a very short place means that you're going to have high winds. So the speed of the wind is based upon the differences in pressure. So if I had something like 5,000 millibars and 1,000, it would have a severe wind. But if the closer that you can get those differences apart, so the closer that a high pressure is to a low pressure, the more violent the winds can be. And so the winds often are not our enemy, but when they are, they can really, really cause damage. They can completely knock your house down. All right, so there's two basic kinds of forecasts. You have digital forecasts, which is using computer modeling. Remember, that's basically a math algorithms, and they're putting in all the data for every point that they can find. So if they know the temperature at every location, they know how much humidity is in every location, they know all kinds of things at every location, then they put that into a high density computer. They can often make a forecast of what is likely to happen, especially in the short term. An analog is more of a old style way of doing a forecast, where you would say, if we had these conditions in the past, 30% of the time we would have rain. And you'll end up with the 30% chance of rain, or 30% chance of snowstorms or showers after the sun goes down, or something like that. So analog is, it's not that it's not using data, it is, but a lot of times it's an analogy. It's using past events to say, most of the time when we had this situation, this is what we expected. Okay? And digital is looking at current positions everywhere, and then from those current, what is likely to happen under this condition. So there's lots more data normally in a digital situation, and that is where the weathermen all use large computers to do this. So a digital forecast is more accurate because it's looking at every little place rather than simply when we had this temperature and these winds, we normally got rain or not. That's more of an analog consideration. The shorter term into the future, the easier it is to see. The longer into the future you go, the harder it is to see, because there's just too many variables. Too many things could change, and as they change again. So if you have a change in pressure, then that changes the wind. If the change is in wind, that changes the direction of the weather. If the temperature goes down or up or whatever, all kinds of things can happen. So the farther you look in the future, the more iffy your results should be, and the more with a grain of salt that you should take it. So short-term forecasts are usually up to 3 days, and they're relatively accurate in terms of temperatures. They can also be accurate in terms of big weather events. So it is possible to predict a blizzard if you have serious weather coming up on your west. And remember, wherever the prevailing winds are blowing, you're looking for the winds to move that weather system along. So you can say, if there's a blizzard in Nebraska, I bet you in 24 hours it'll be in West Virginia. It's that idea. Long-term, say for an entire season or an entire year, like an almanac, much more hooky-pooky, and a lot of times you're dealing with big data. So how dry has the summer been? Well, you can make some guesses as to what the fall will be like, or how wet has something been, or how much moisture do you have. You can make big predictions, but the longer you go, the iffier they are.